So, good afternoon, everyone. Sorry, good evening, everyone. In fact, I hope everyone is doing great. And this is lecture number 2 in wave optics, and we were dealing with some basic terms in wave optics. Remember, this chapter is all about understanding those terms, and if we understand those terms, we would be doing good. We had seen the equation of a particle executing SHM or a wave, and we had seen what do you mean by phase, what do you mean by leading, what do you mean by lagging, what is displacement. We have also seen in the last class that we were doing that what do you mean by phase difference, difference in angle is phase difference, path difference, and time difference. Do we remember this? Yes or no?
Yes.
Now, in short, what you can say, if I just try to summarize everything with a formula, what we can say is a phase difference of 2 pi is actually equal to a path difference of lambda, which is equal to a time difference of t. So if I have to convert phase difference into path difference, phase difference into time difference, I can use this formula. Let me write it in that way. Phase difference delta phi divided by 2 pi will be equal to path difference delta x divided by lambda will be equal to time difference delta t divided by the time period. This formula will help me in converting any phase difference or path difference or time difference into the other quantities. This is a formula that you must remember because you would be needing this while you are solving any questions in this particular chapter, because it's all about path difference and phase difference and so on. Let us try to utilize this and solve a question. 2 points or 2 particles, if I can say, 2 particles differ by a phase of pi by 3. Remember, whenever we talk about phase or phase difference, we always talk in radians and not degrees, because radian is the SI unit. 2 particles performing SHM or in a sinusoidal wave, they differ by a phase of pi by 3. Find the path difference. Delta x, remember, is path difference, and delta t is the time difference between the 2 particles. So that is the question that we are looking at. 2 particles is given to you, differing. They are not in the same phase. They have a phase difference of pi by 3. Can you tell me what is the difference in their paths and what is the difference in their times? 2 minutes you will have. Anyone with an answer?
Delta x is equal to lambda by 6.
What about the time difference, beta? You have to tell me both the things, time difference and the path difference.
Delta t is equal to t by 6.
That is correct. The path difference is lambda by 6 and the time difference is t by 6. That is correct. What about the others? We have got the answers. Anyone?
We are doing, sir.
Okay, I'll give you 1 more minute to do. Remember, the only thing that is in our hands is that we keep on trying. No one can take that away from us. And if you try hard, we shall end up with the answer. So how are we supposed to do this if we are supposed to do this? The relation is already there, written here. This is the relation that we know. So basically, I write the same thing. Path difference delta phi by 2 pi is nothing but equal to phase difference phi, delta phi by 2 pi is path difference delta x by lambda. From here, I can write delta x, the path difference will be lambda by 2 pi multiplied by the phase difference. I can just now put the values, get the answer, and stay happy. So what will be the answer here? The path difference will be equal to lambda by 2 pi multiplied by pi by 3. Pi cancels. Oops, so I'm writing pi again. If the pi is cancelled, the answer becomes lambda by 6. So if they differ by a phase angle of pi by 3, which actually is 60 degrees, the path difference between them would be lambda by 6. Do we understand this, everyone? Raise hand will give me more confidence that we are in the same universe. Great. Now, similarly, you can find out the time difference. To find out the time difference, you can use the next formula. I mean, there's the same formula, there's only one formula. So you can write delta phi by 2 pi will be equal to delta t by capital T, time period. Now you can write the formula for delta t. Delta t will be t divided by 2 pi multiplied by the phase difference. You now only need to put the values, get the answer, and stay happy. T by 2 pi multiplied by pi by 3. Pi cancels, and you get the answer as t by 6. Do we understand this? Yes or no? No, yes.
Yes, sir.
Everyone? So if you know the phase difference, you will know the path difference. If you know the path difference, you will know the phase difference. Okay? Got it? Now this path difference, phase difference are going to come in a variety of problems. In most of the problems, you will not be given the the phase difference, but you will be given the path difference. And from path difference, you will have to calculate the phase difference. I understand that since you know the formula, it's very easy. But in some more problems, you will not even be given path difference. You might be given a question, and then from there you will have to find out the phase difference. So there you must be careful of what you are doing. For example, if I would devise a question to make you understand the phase difference and path difference concept, suppose this is a point A. Now this point A is getting rays or waves from two sources. This is source S1, and let us say you might have seen such problems in sound waves. This can be sound waves, wave, whatever wave, sound wave, light wave, any wave, same interference, same thing happens. So you have two sources. They can be sources of sound, they can be sources of light, whatever. They are emitting waves. If I say that this distance is A and this distance between S1 and S2 is B. Now, wave from S1 is also reaching point A, yes or no? Is also reaching point A. At the same time, your wave from, I will draw straight line, the wave from source 2 is also reaching point B. Yes or no? Yes or no? Are
Yes.
they traveling the same path? Are they traveling the same path?
No, sir.
That means they are not traveling the same path. That means they have a path difference between them. Yes or no?
Yes, sir.
If they have a path difference between them, that is the question. Find out the path difference. And once you know the path difference, find out the phase difference between the waves arriving at point A. One wave is coming from source S1, ding. The other wave is coming from source A2, bling. What is the path difference and the phase difference between the two waves that are arriving at point A? Your time starts now. Remember, it's a simple question. Now, this same question has come in JEE many times. Many times. Many times.
Path difference.
Shall I help you?
Yes, sir.
No one got any answer? Okay, it seems like a very tough question to trust me. It's a very simple question. The first thought that should come to your mind when you look at any question is that that question is simple. Do we understand this? This question is simple. And when I do it, you will understand, oh, it was so simple. I want to give you 1 more minute, right? Just find how much S1 is traveling, just find how much S2 is traveling, and you are done.
Sir, can you give us hints?
I told you, I just now gave you a hint. Find out how much distance this pink wave is traveling. Find out how much distance this green wave is traveling, and you are done. Path difference. What's path difference? Shall I do it? Okay. It seems like I have to do it. Okay. It seems
Delta
like
x is equal to t by lambda under root a square plus b square minus a.
delta x is t by lambda. T, how did you get t? From where did you get t? What is t? Okay. I think you got the right answer, but probably I'm not able to understand it. Now, which one is traveling more? The green one or the pink one? Which one is traveling more? The green one or the pink one?
Green one.
Green, sir.
That's it. How much is the length from S2 to A? How much is that? It is
Root over a square plus b square.
root over A square plus B square. So the path difference, my dear friends, the path difference, my dear friends, is S2A minus S1A. It does not get simpler than this. How much is S2A? Root over A square. Oh, why I'm writing minus? Root over A square plus B square hypotenuse minus A square. I think you're not able to see the screen.
The screen is paused.
Root over A square plus B square minus A square. S2A is the hypotenuse. S2A is the hypotenuse minus A square, and that is the answer, my dear friends. That is the path difference. How do you find out the phase difference from the path difference?
Sir, y a square.
Yes, bacha?
Y a square.
Sorry, minus A, sorry. My mistake. Root over A square plus B square minus A. That is it. How much is the phase difference?
I times root over a square plus b square minus a by lambda.
Yes, to multiply this entire thing by 2 pi by lambda. That's it. And you get the phase difference from the path difference. It is as simple as that. Now, many a times when this question comes, this looks very complicated. I mean, the path difference looks very complicated. So what they do is they give you a special condition. And the special condition they give you is this A is very, very large compared to B. That is the condition that they give to you normally. Just for this expression that I have here, just for this expression to look a bit more simpler than this is actually is, they give you a condition that this A is very large compared to B. Now, what difference does it make to this expression?
It will become 0.
No, it will not become 0. It does not become 0. What does it become? So what do I do then? The pink one is the right answer. But if I put the condition that A is very large compared to B, I can write this equation as, and this is all maths. Physics has got nothing to do with this. I can write the equation as A square plus B square raised to the power half minus A. Yes or no?
Yes, sir.
Okay, let me just take this off because I might need more steps. Okay, so I can write it as A square plus B square half. Then what will I do in the next step here is I will take A square common. So I will write this like this. a square into 1 plus b square by a square, the whole raised to the power of 1 by 2 minus a. I can write it like this, yes or no?
Yes, sir.
It's simple maths. Simple maths. Now I can take this a square. See, this is maths. I'm not doing anything. I can take this a square out of this root. A comes out. Yes or no? So now in the next step, what I have is a into 1 plus b square by a square raised to the power half minus a. So far so good. Nothing I have changed. I've just done some simple maths. Yes or no?
Yes, sir.
Now from here we apply something which is known as binomial expansion. Have you heard about binomial expansion?
Yes, sir.
We apply binomial expansion on this. What does this binomial expansion say? So I will write it here. If I have this expression 1 plus x raised to the power n, and this x is very, very small compared to 1, I can write this expression 1 plus x raised to the power n as 1 plus nx. Have you seen this? Yes or no? This
Yes,
thing
sir.
that I have written in this is binomial expansion. Do you know this binomial expansion? Well, if you don't know, you can just see it and remember it. So the expression has to be in the form of 1 plus something. 1 plus something raised to the power n. If that something is very small, can be written as 1 plus nx. Do we understand this?
Yes, sir.
If you understand this, then we can move on to the next step. Remember, what I'm doing is not physics. This is purely maths. And maths sometimes may get into more steps. So now what will I have? I will have a, and I will put this expansion here. This half is actually your n. Do we understand this? So I will write 1 plus nx. So 1 plus nx means, oops, wrong color. 1 plus n is half b square by a square minus a. And then I can do a bit of simple maths. 1a will get cancelled, and I will end up with this answer, b square by 2a. That becomes the part difference. And this is purely maths. It has got nothing to do with physics. Do we understand what I have done?
Yes, sir.
This is purely maths. Pure maths. Nothing of physics. Physics only end here, probably. This is probably physics, the first and the last step. After that, it is all maths. You only should know in physics what do you mean by part difference. The green ray moves like this. The pink ray moves like this. This distance minus this distance, that is physics. Rest is all maths. We understand what we have done here, yes or no? So,
Sir.
a very simple concept of part difference, just because of some conditions given here, and the condition given here was this, it becomes from this value, which you see in pink, from this value, it goes on and becomes this value that you see finally coming up just because of some shortcuts in maths, some binomial expansion in maths. We get this, yes or no? I'll give you 2 minutes to go through this. And remember, these questions are only going to come in JEE Advanced. JEE Main does not have these. So take a deep breath and then see for yourself how it is done. If you have any doubts, please let me know. Take your time.
Completed, sir.
Everyone have understood this?
Yes, sir.
Boys?
Yes, sir.
Well done. So this is how you can convert what you can convert. A problem where nothing was given to a problem where you know how to find out the part difference to a problem to know the phase difference. Now, what will you do after finding the phase difference? Just finding the phase difference might not be your question. Just finding the phase difference might not be your question. Your question might be something totally different. But this finding out this phase difference is just one step of the question. And that question only comes in JEE Advanced. So JEE Mains they might only ask you the part difference and they are done. They might only ask you the phase difference and they are done. Okay. So now what comes next? And what comes next is the next heading of this. Have you understood this? Or do you want me to do one more problem or you are done? You understand part difference? Yes or no? Okay. What comes next is known as superposition of waves. Superposition of waves. This is also valid if the motion is simple harmonic. You can call it superposition of simple harmonic motion. You can call it a different way, different name, superposition of waves, whatever. We are doing the same thing. Now, what do you mean by superposition of waves? This concept is somewhat similar to what you might have heard. Superposition of forces. Do you remember I told you some 1 year back, 2 year back, superposition of forces? Did I tell you that? Superposition of forces? Superposition of vectors, superposition of electric field, superposition of electric force. Have you heard these terms? No?
Yes, sir.
What do you mean by superposition of forces? Can anyone explain what do you mean by superposition of forces?
Summation of all force.
What beta? Combination of all force. Is that
Sum
what
of the all force.
sum of the all force? Okay, that is superposition of forces, right? So basically what it means is, in terms of forces, what it means is, if at one point there are a number of forces acting on a body, say F1, it is a vector, say F2, it is a vector, say F3, again a vector, and so on. There are n number of forces acting on a body. I can find out the net force. Net force is F1 plus F2 plus F3 and so on. This is known as superposition of forces. This is valid for any type of vector that you deal with. Now, why this principle is valid? Because these forces are independent of each other. They don't depend on each other. F1 will act no matter F2 acts or not. What F2 is doing, F1 has got nothing to do with it. F1 is because of some other reason, F2 is because of some other reason. They don't depend on each other. They don't influence each other. Therefore, the net force acting on the body, if there are more forces acting on a body, can be written as the vector sum of all the forces. Now, the same principle can be applied for waves. Now, when a wave is traveling, when a wave is moving, when a wave is propagating, the particles are oscillating. They are moving up and down. You might have seen a water wave. When you create a wave in water, the wave moves like this forward, but the water particles are moving up and down. Do we understand this? Wave is moving in the forward direction. Water particles are moving up and down. Those waves are known as transverse wave. Direction is like this. Particles are moving like this, perpendicular to them. Okay, so whatever happens, whenever there is a wave traveling, wave moving, wave propagating, particles are moving. Now, if one wave is moving and in the same medium, other wave is also moving. Now, sound is a wave, right? Right now, you are hearing my sound, but at the same time, you're also talking with each other. So you can hear each other's sound as well. That sound that you're hearing from your friends or the fan that is running the fan that is on. You can hear that sound distinctly. You can also hear my voice distinctly. My voice is not affecting the voice of the fan. My voice is definitely not affecting your chat, which is happening. That means all these waves, they are traveling together in the same medium. The medium is your room right now. I can also hear a variety of voices. I can hear the voice of my son who is doing something in the other room. I can hear the voice of this. I can also hear you in between whenever you talk. All the waves are traveling in the same medium. Now, when all these waves are traveling in the same medium, the same particle, it is getting influenced by one wave. It is also getting influenced by the other wave. So if there's a particle here, because of I am speaking, my sound wave is moving. Because of this, the particle is moving. The other sound wave is also moving. Because of that, the particle is also moving. But my sound wave, my wave, and the other wave, they are independent of each other. They don't depend on each other. Therefore, if I have one or more waves in the same medium, if I call the first wave as y1, and if I call the second wave or the second wave as y2, and if I write y1 as sine omega t, and if I write y2 as a2 sine omega t plus phi, these are the two waves that I have written. I have written them specifically in a specific way. Something I have taken as same, and some things I have taken as different. What things I have taken as same and what things I have taken as different? What things I have taken as same and what things I have taken as different? Yes. Yeah, I've asked the same question yesterday. Yes, my dear friends. What have I taken same? What have I taken different?
Phase is different.
Phase is different. Okay. If I look at this yellow gentleman here, the face of this gentleman is omega t. The face of this gentleman is omega t plus 5. Phase is different. Anything else that you find different?
Amplitude different.
Amplitudes are taken as different. So I talk about the green ones. The amplitude of this wave is a1. The amplitude of this wave is a2. Well done. We are talking. Yes. What else do you see? Same or different?
Angular velocity and time same.
Time is not same. The time is variable because I can put different values of time. The first equation is written as a function of time. The second equation is also written as a function of time. So time is not same. Do we understand this? Omega is same. Do we understand this? What I'm saying? This equation is written as a function of time. So time is not same. I can put different values of time and I can get different displacement. Do we understand this? So time is not same. Everyone understands this?
Yes, sir.
Okay. So phases are different. Amplitudes are different, but omega I have kept same. Why I have kept the same omega? Because for different omega, that is not in your course. So that is why I have not made omega same. So these waves or these displacement are having same omega, but they have different phases and they have different amplitudes. Now, these are the displacement produced by the individual waves. Now, if at one point this wave is coming, tung, 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 it is causing a displacement. At the same time, this wave is also coming, tung, 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 and it is also causing a displacement. What will be the net displacement of the particle? Let us only take two waves because we'll only be dealing with two waves. What will be the net displacement of the particle? One wave is coming, other wave is also coming. Yes. What would be the net displacement of the particle? Remember, we are doing superposition of waves, and you can take inspiration from what is drawn on your on my whiteboard that you can see. Yes. What do you think would be the net displacement of the particle? It's not rocket science. It's right there in front of your eyes, written. The net displacement of the particle would be
Vector addition of waves.
waves don't add vectorly, okay, but it is the addition. But you are right in one way, because we are going to add them as vectors because they are not in the same phase. So the net displacement will be y1 plus y2. So you can relate this superposition of waves with superposition of forces. Net displacement will be equal to this. Now how I'm going to add this is I'm going to write this as a1 sine omega t. If omega becomes different, the addition becomes very, very difficult. Right now, even also it is not so simple. Plus a2 sine of omega t plus phi. So far, so good. We understand up till here. Superposition of waves. Yes or no? No or yes?
Sir.
Yes, sir.
Now the problem is, how do we add this? And who is going to solve this problem? Whenever physics faces a problem, its distant cousin comes and helps it. What is that distant cousin's name? What is that distant cousin's name that helps physics whenever physics is caught in a soup? What is the name of that distant cousin that helps and helps physics whenever physics is in trouble? That distant cousin is known as maths. Maths comes and rescues us. So how do we add this? We draw them like this. Now, out of y1 and y2, someone is leading, someone is lagging. Which is leading, which is lagging? We have done that yesterday. Which wave is leading, which wave is lagging?
Y2 is leading, sir.
Y2 is leading and y1 is lagging. Yes or no? So what we do is, this is all maths and it will remind you of something. I will draw the lagging wave first. I draw the amplitude. And then I draw the leading wave. It is leading means it is ahead. And it is ahead by an angle of phi. Do you see this phi? This phi? This phi. So A1 is here and A2 is ahead. So therefore it is ahead. Anti-clockwise angles are positive. So it is ahead. Do we understand this? Now it looks like vectors. It looks like two vectors. One vector A and one vector B. Both the vectors are inclined at an angle theta. If you remember the formula, we can find out the resultant of these vectors R, which will be inclined at an angle, let us say xi. I'm not using phi because I'm using phi here. You can find out the value of this resultant. What was the value of this resultant? Tell me. What was the value of this resultant?
Under root a square plus
Yes.
b square plus 2ab cos theta.
Under root of a square plus b square plus 2ab cos of this theta. Well done. That was the resultant of these two vectors. You can also now tell me, how did you find out this angle phi or xi that I've written? You can also find the tan of this xi. What is the tan of this xi? It was b sine theta upon a plus b cos theta. Yes or no, my dear friends?
Yes, sir.
Here also, I have to do the same thing. I have to add these two, and they are now looking like vectors. They are actually not vectors, but they are looking like vectors. If I say that the resultant amplitude is A and it is inclined at an angle xi, without I telling you the answer, can you tell me what will be the value of this A?
A1 square plus A2 square plus 2A1 AB cos theta.
A1 square plus A2 square plus 2 times A1 A2 cos of phi. I'm using phi because phi refers to the phase difference. You can also tell me the value of tan of xi. What is the value of tan of xi?
A2 sin pi by A1 plus A2 cos theta.
Phi, not theta, phi. A1 plus A2 cos phi. Do we understand this? Yes or no?
Yes, sir.
But remember, I had to find out the value of this y. I had to find out the value of this y. What is the resultant displacement y? That is what I had to find out. But what have I done instead is I have found out this a and I found out this I. Remember, my task was to find out the value of y. Can anyone tell me what is y? How much is the value of y? Because you can see I had written y1. I had written y1 in some form. And as you can see, I had written y1 like this. Oops, wrong color. I hate wrong colors. I had written y1 like this. I had written y2 like this. How do I write y? The question was to find out y, and I found out something I don't know what. How do I get y? How do I get y? I have to write y in the form of a wave because this is again a wave, displacement of a particle. How do I get y? I have to write y. I have to write y. I hope you understand my question. Yes or no? No or yes? What is the value of y? What is y? And y is. Now look.
A sin omega t plus phi.
Plus phi. Think again. Think
Yes,
again. Think again. Y is. You are right. Y is.
A sin omega t plus
A,
psi.
yes. A sine omega t plus xi. This xi. This xi. This xi comes here. And this A comes here. That is my answer. That is my resultant displacement. And I've done it beautifully with the help of vectors and with the help of maths. Otherwise, by physics, it was very difficult to do. This is how I've added the two waves. And this principle is known as superposition of two waves. Whenever two waves are traveling in the same medium, the resultant displacement is the sum of displacement produced by the waves. This principle is known as the principle of superposition of waves. Do we understand this? Yes or no? No or yes?
Sir,
Yes, sir.
So I will request you to write the definition of superposition in your own language. And what will you write? Whenever two waves are traveling in a medium, what happens then? The resultant displacement at any point is the what? Huh? The resultant displacement is the sum of displacement produced by the two waves. Have we noted down this whatever
sir,
have we noted this down?
noted, sir.
Everyone has noted this down. So superposition, the principle of superposition simply states that whenever two or more waves are traveling in the same medium, the resultant displacement is the sum of the displacement produced by the two waves, and we have seen the superposition of two waves. Then sometimes we get this term which is known as interference. And sometimes we get to we hear this term interference. Now, what do you mean by interference? Anyone? What do you mean by interference? What do you mean by interference? Now, interference is superposition of waves, but it is a very special type of superposition. It is a very special type of superposition, and I think I will show you that right, and then we will write it in terms of points because it is better to understand the same thing in terms of point. So, what is interference? When two waves of exactly same frequency. So the first point that you must write is they must be of same frequency. Do we understand this? When I say same frequency, I mean the value of omega has to be same. Now see the two waves that we had superimposed, they had the same omega. Yes or no?
Yes, sir.
Okay. Same frequency coming from two coherent sources. So they must be coming from coherent sources. So that is one term that we will do in the next class. So they must be coming from coherent sources. Coherent sources means the sources produce same frequency with constant phase difference. Constant phase difference. Phase difference should not change with time. Phase difference should remain constant. Those sources are known as coherent sources. We will do this coherent sources in the next class. Traveling in a medium in the same direction. So the third point is they must travel in the same direction. So what happens when two waves of exactly same frequency coming from coherent sources which have same or constant phase difference, they travel in the same direction. At some points, intensity of light is maximum, while at some points it is minimum. This phenomena is known as interference of light, or for that matter, sound or whatever. So for interference to happen, interference is a type of superposition. But in superposition, we can have two waves of different frequencies. They might be traveling in different directions. Here, two waves, same frequency, same or constant phase difference, traveling almost in the same direction. Three things. We have put three conditions here. That is the difference between superposition and interference. Do we understand this? Yes or no? No, yes.
Yes, sir.
I hope we have noted this down. We will take our class forward in the next class on interference and try to wrap up interference and your YDSC into, I'm thinking of 2 classes. So probably we'll be able to wind it up by the next Monday. I think. Yes. Okay. So we'll meet in the next class. I hope you have noted everything down. Anyone has any doubts?
No, sir.
No, sir. Then take care, sir. And may God bless you, sir. Bye-bye. I'll see you in the next class. I have to go for the next one. Take care, beta.
Bye, sir.
Bye.